All right, so let's continue with our code today. Okay. So last time we are left to show that this image of this unit disk under this FD cannot contain a disk of radius cannot contain a disk of radius 1 over theta r times modulo of the prime theta. Okay. So what's the case? So so here okay. So what we know is that this so we know that this image of this disk under this bending phi cannot okay a disk of radius 1, right? Okay. Where this r is like the radius where the original function is being defined. Okay. So why is the image of D under this F cannot contain a disk of radius 1 over theta r? Okay, so what's the relation between this F and phi? So basically, you know that this we know that this Fg is equal to, so first the input is Z, and then you shift it by so okay, so you shift so basically what you do is that you multiply it by a factor of 1 minus theta r times Z, right? So basically what you can think of is that you can think of like, so this is like the Z plane, right? Z plane, and then you do a dilation, right? So you do a dilation, and then dilation by a factor of 1 minus theta rz. Okay. So okay. So what happened? So I want to okay. So okay. So let's say that this f is being defined on wait, where does this f is defined? So let me check. Okay, so this fz is being defined on the unit disk. Okay, so sorry, I made it last slide. Okay, this f is being defined in the unit disk. So take this unit disk, and then you dilate. So when you dilate, the radius actually becomes, I'm not sure, bigger or smaller. Yeah, doesn't matter. So it becomes a radius of, let's say, so this r, I think, is arbitrary, right? So there is no restriction about this r, right, initially. Where? Yeah. Okay. Okay, so this R is like can be arbitrarily big actually. Yeah. So we will dilate it. I think probably it could get bigger, right? So let's see. 1 minus. So this is the disk of radius 1. So and then you dilate it. It becomes a disk of theta 0 radius 1 minus theta r. Right? Yeah. So just making sure. So you have a z here, Okay, yeah. And again, and then you move about, you shift it by a zeta, right? So you after that you do a transfer. Let's say that the center becomes zeta now. Okay. So when you do that, now maybe let's say here you have this one. Okay, and then this D center at zeta of radius 1 minus the same radius as this one, right? Alright, so now what happened? So so then you take the phi, right? Wait, hang on. So okay. So so this zeta is okay. Shoot. Okay. So this is what's up. Okay. So this zeta is in where? Let me see. Okay. So this zeta is actually in the center at 0 of the radius phi r, right? Okay. Okay. Yeah. So the whole thing cannot be extended to the disk of radius r. That's what I'm trying to say. Okay. So yeah. So this is like the radius r, maybe like here. Okay. So yeah. So basically the idea is that this so this phi it has module less than phi r, and then the whole thing add up to r. Okay. All right. So let me check. So the thing is. Okay, so now, so this is like the input for this, so we'll input a z, so this is like the input for this f, any z here. After that, a dilation maybe becomes somewhere here. After you add it, maybe it becomes somewhere here. And then you apply the phi to it, right? You apply phi. So, okay, so it says cannot contain a disk of radius 1 minus 1 over 1 minus theta times r divided by. Okay, and then so so here this question is saying that this phi of okay, so basically we know that this phi cannot contain a disk of radius 1, right? So let's see. So if you have phi, so phi is being defined over, okay. So phi is being defined over the whole disk. Okay. So this is domain of phi. Okay. And then okay, and then we take a f. Okay. So and then fz is over this whole thing over what? Over 1 minus theta r times psi phi theta. Okay, so this is what f is defined as. Okay. All right. So okay. So okay. We want to show that this phi cannot contain a disk of radius. Oh, sorry. We want to show that this f cannot okay. We want to show that this image, okay, this image under Fz cannot contain a disk of radius. Oh, okay. Okay. I think it's really straightforward, right? Because you see that this if you take the image, if you take any value z here, dilate it, and then add a zeta. So this value is still inside the disk, namely it's still inside this domain of phi. So therefore, since phi, the image of so the image of phi cannot contain a disk of radius 1, right? So the image of phi cannot contain a disk of radius 1. So therefore, so I think the idea is that when it's like you are shrinking the disk, you are shrinking the image, right? So when you shrink it, I think this should also be shrinked. Okay. I think here this is the argument. So okay, how I gonna? Okay, so I think that's the case, but I don't think I can prove it right now. So maybe I'll leave it to you as an exercise to do that. Okay, so then it follows that, okay, so because we know that this f is, this f satisfies the collision for the block theorem we showed last time, right? So, okay, so therefore we know that okay, so we know that the block constant of this f is actually, wait, I wanted to show one thing. So, for the block theorem, okay, never mind. So we know that this block constant is less than 1 over 1 minus theta r b y theta. Okay. So, and then that is, okay. Okay, so now, okay, so, okay. So trivially, last, so this inequality, this inequality is valid even if this theta prime phi is equal to 0. And yeah, so this one is true even if this phi prime theta is equal to 0, right? So I think the key is that because okay, never mind. So, okay, so here it says something about, and therefore, the condition psi prime, oh sorry, for phi I mean for psi, okay, sorry. And therefore the condition for psi prime theta is not equal to 0 may now be discarded. Psi prime theta not equal to. Oh, okay. Yeah, I'm not really psi prime. All right. Okay, so here it says the condition. So in the notes it says the condition psi prime theta not equal to 0 may now be discarded. I'm not sure what this reading is saying here, but maybe that's just okay. Yeah, never mind. Okay. So okay, we'll figure out later. Okay, and I don't think it's yeah, stable. So okay, so sorry. Therefore, okay. So okay. Again, we have the so using this identity. So the point is that we want to have an upper bound for this psi, right? So and then after we find the upper bound for this psi, we have a upper bound for this f. Okay. And then after we found the upper bound for this f, I think we're So after we find the upper bound from F, what happens? Yeah, so we are done. Okay. Okay. So the thing is that okay. So now we are allowed to find the upper bound. So here, so remember that we have the complex integral to be less than equal to integral over prime beta d beta. Okay. And then so this is less than equal to wait, should I do something? Okay, yeah. So okay, so okay, so basically you are taking the complex. Yeah, so you are taking the yeah. Yeah, you're integrating along any path, okay? Integrating along any C1 path, I think, from 0 to theta r. And then you take the derivatives, and then d theta where you can, yeah. And then it's less than equal to modulus of d of 0. So okay, so we know that this guy we know that this guy is bounded, right? So and then okay, and then this okay, d beta, I think. Wait, what about? Okay, never mind. So what is d beta? Oh. Okay. Okay, I see. So let's just keep it. So then I think the total length is theta r, right? So I think what you get is you get yeah, so you will get this one, okay. Okay, so the idea is that basically, yeah, it's equal, yeah, so basically, yeah. It just learns all this one, okay, anyway, so, I don't know why yeah. Okay. Okay, so, okay. Okay, so, okay, so here it says denote the rightmost element by row. Okay, what is row? Wait. I don't think there's an issue of sequence in zero. Okay, never mind. Okay, never mind. Okay. All right. So let's see. Okay. So. Okay. So what is f? So we know. Okay. So we know that if f is okay. So we get a okay. Okay. Denote the rightmost by row. Okay. So let's call this one row. Okay, we'll figure out what row is. I think yeah. Okay. Just let this be row. Okay. So and then fz. Okay. So what is f in terms of okay? Okay. Okay. So okay. So okay. Okay, I think fz is being defined as e to the minus 2 psi plus e to the 2 psi, right? I think. Okay. Oh, shoot. Okay, so it's more complicated than I thought. Sorry. Yeah. So this f is, oops. Yeah. Okay. This f is a minus e to the pi I over 2 of this e to the 2 psi plus e to the negative 2 psi. Okay. Psi z, sorry. Okay. So now, okay, so we know that this modulus of psi, this psi z is, oh, I forgot to add the absolute value sign. So, okay. So we know that this fz, we know that this psi is bounded by this row. Okay. So what about this f? Okay. So what about this f? So okay. So let's check. So so do you have this modulus of e? Let's see. So this modulus of f is minus modulus of e minus modulus. Oh. Sorry. Modulus. Okay. Okay. So you have e to the. so you have e to the ai plus b, and then which is equal to e to the ai e to the b. This is is the imaginary part, and then we know that this is okay. So wait. So actually, wait. Okay. Okay. Never mind. So so you take the modulus. I think what you get is e to the b, right? And then we what? Wait, let me see. Okay. Okay, never mind. So let's see here. What do we have? Okay, so we have this modulus of fd is equal to modulus, and then is equal to modulus of e to the why do we have that? modulus of phi z is less than rho, right? So what happens? Ah, okay, I see. Okay, okay. So I think, okay, so I think the thing is that this okay, okay, okay. Okay. So I think this is true, right? So okay. I think this is true. All right. So now what happened next? So the thing is that this guy is less than equal to e to the modulus of absolute value of b, right? Absolute value. So right. Yeah. Wait, why? Yeah, because in this case, this b is a real number, right? Yeah. Okay. Why? Okay. And then this yeah. So this is a real number. This is a real. Okay. And then this e could be either positive or negative. If this b is negative, then it's 1 over e to the wait. Hang on. Let's see. So if this b is a positive number, then it's holds, right? Same thing. Yeah. Yeah. Same thing. So and then if b is negative, okay. So if b is negative, then this is equal to 1 over e to the modulus of b. Okay. It is still less than equal to 1 e to the modulus of b. Oh, sorry, the alpha value b. Let's see. Definitely, okay. So if B is between, let's see, if I want to say that if this B is between, is equal to 0, then nothing happens, right? If everything is equal to 1. Okay. So I want to say that if B equal to 1, oh, I think it's the other way. So, so if B is equal to -1, what will happen? So 1 over E, and then this is the E, that's definitely true, okay. So if B is somewhere between, so negative number between 0 and -1, so the thing is that, you will have, oh, okay, okay. So here you will have e to the like 1/2 power. So I think this number is bigger than 1, right? So e to the any positive number, right? So modulus b is a positive number. So e to the any positive number is bigger than 1. Okay. So therefore, this e to the whatever positive number, this is bigger than 1, and then 1 over this number is less than 1. So this is always true. Okay. And then when b is, yeah, I think it's when b is that when b is even lesser, like a -2 or something. So it will still hold, right? So if b is -2, this, okay, yeah, it will still hold. So and then b is positive. Okay, yeah. So this is true in general. Okay. So then what happens if okay. Okay, so what happens if, so basically we have to think that, because this guy, I know that it's definitely less than equal to e to the absolute value, modulus of ai plus b, right? Okay. Why? Because, yeah. Okay, what happened? Okay, so I'm worried about if it is like oh, it's like 1/2. I'm wondering if it's 1 over 3 or 1 over 2. So okay, never mind. I think it's true. Okay. Okay, so okay. Alright, never mind. So alright. So yeah, so we have this. So therefore what we have is that modulus of fz is actually yeah, I think we get the equality. So yeah. Yeah, so this is less than equal to this e to the modulus of things at the top, which is pi over 2 times the modulus of these two, which is less than equal to the modulus of the thing that on the top, right? Yeah. So yeah. or I think it's negative here because if you take the triangle, if you take the triangle inequality, it actually gives you a negative. Okay. Okay, I think we have it now. So let's see. Oh, anyway, it's you think it's positive. Okay, it's still true. Okay. Wait. Okay. Okay. So therefore, we know that this X is bounded. Okay. And then therefore the theorem so notice that this right hand side depends on this modulus of wait what so the right hand side depends. Okay. So why is it depends on theta? Oh, okay. f based on sine. Choose this f to be what? Choose this f to be b prime zeta, right? It depends on. So y is this. The right hand side depends on only y is only, so it's rho, right? So y rho is depends on, oh, okay, 5.0, okay, minus e1 zeta. Okay, so this theta is what? This theta is this theta is what? Okay, the theta is any theta. Take is between 0 and 1. But y is so y is any theta. Okay. Okay. Okay, so what I think, is this theta arbitrary? Yeah. I think this theta is arbitrary between 0 and 1, right? Okay. So, but y is saying, okay. So it only depends on depends on side 0. The right hand side depends on okay, and theta only, okay. Oh, I see, okay. Why it is saying that it depends on okay. Wait. Okay, I think I miswrote something. Okay. So here it should be not derivative, but yeah. Sorry, maybe but y is this block constant depends on what? This block constant depends on okay, so this block constant is about f, right? For any zeta. So this block constant, oh wait. Okay. so okay, so here he is saying that this block constant, it doesn't depend on this f. Okay. As long as there's a function analytic on a unit disk and satisfies this f prime 0 equal to 1, then there is a subregion omega of B that is mapped uniquely by f. Wait, what happened to this omega? Okay, never mind. This omega doesn't matter. Okay. But the thing is that the image of the disk will contain a disk of radius b. Okay, that's the thing that matters, right? Okay, so now the thing is, so here we have this f. Okay, this f depends on psi, and also wait. We know that this b block constant doesn't depend on f prime 0. So wait, I think it wait. So this b depends on what I would say. What I want to say is that okay. Okay, I think the thing is that as long as we, so this block constant really doesn't depend on f. Okay. Yeah. This block constant really doesn't depend on f. It is just a constant number. Okay. So as long as any function satisfies the condition of the block theorem, then it is guaranteed that the image of the function is it will contain a disk of radius b. Okay. Okay. So this block constant, it has nothing to do with anything here. It's just a constant here. Okay. So here, the thing that matters is Okay, so we know that this inequality, it depends on this rho, right? So this rho, so this is just a constant, doesn't like depend, it's just an absolute constant, okay. And then also depends on this phi of 0 and this theta, right? Oh, okay. So, alright, so alright, so okay. And remember that this phi of this phi of 0 also depends on oh, okay. So we are here. We are saying that we are choosing the phi 0 consistently, right? To be a number, right? So okay. Wait. Oh, okay. Okay, I see. Okay. It's yeah. The reason why he is saying that we choose the phi 0 in a consistent way is that no matter what your f is, as long as this f of 0 is equal to alpha, remember that for each f you can yeah. Oh wait. Okay. So yeah. Oh, what is f? Okay. Remember that for each f, you are allowed to pick this phi up to like additive constant of yeah. Okay. So for each f, you can pick I think h, right? Up to like a plus or wait. Wait. Okay. So we know that this f wait, what is f? Okay. This f is equal to e to the 2 pi I hz, right? And then once wait. Okay. So there Okay. So there okay. Okay. Yeah. So the idea is that we can okay. Yeah, the idea is that we can pick this yeah, this video is consist. Okay, we will do it. Yeah, so yeah, so I think yeah, we have mentioned. I think we mentioned before that we can take this phi 0 consistently so that this phi 0 is equal to beta, right? So it is only depends on this f way. Okay. Okay. Yeah. Depend. Yeah. It depends on L of 0. Okay.